Hello, today we are covering lesson 10.7, special segments and a circle. You guys will be able to find measures of segments that intersect in the interior of a circle and find measures of segments that intersect in the exterior of a circle. So we have an algebra review from Algebra 1. We are going to solve the equation by factoring or using the quadratic formula. So, factoring, I would say, is usually the easier way to solve, although it doesn't always work. Quadratic, on the other hand, will always work. There just is usually a little more work that goes along with it. So right up here, I'm going to go ahead and write the quadratic formula as a reference. It is x equals negative b plus or minus radical b squared minus 4 times a times c all over 2a. So that is our quadratic formula. As you learn and use this idea for factoring and quadratic, you'll be able to tell if problems actually work by factoring or if you'll have to use the quadratic. Now, it takes a lot of practice to be able to get that intuitive about it, but I will tell you now that this first problem is able to be factored, and the second one we actually will need to use the quadratic. So problem 1, we are going to factor. So I like to say that we need to find the factors of 8. So the factors of 8 are 1 times 8 is 8 and 2 times 4 is 8. And then we look at the sign in front of the 8. It's addition. Now, real quick, if it is addition, this means that both factors, either 1 and 8 or 2 and 4, have to be positive, so that when you multiply them is positive, or they both have to be negative, so when you multiply them it is positive. Put a little asterisk here if this is actually a negative sign. 1 has to be positive and 1 has to be negative for it to work out. Okay? So keep that in mind. We will have to use this idea considering we need our 8 to be positive. Now, from here, we have to choose one of these two pairs that specifically adds to negative 6. So, the pair that will add to negative 6 is actually 2 and 4. So we need both of these to be negative. So that way negative 2 plus negative 4 can equal negative 6. All right, so our factoring here is x minus 2 times x minus 4. If we were to FOIL this out real quick, this will actually get us back to our original problem. As you will notice. So if you want to check to make sure it will get you back to the original, you can. Okay? That's just a side note though. We didn't have to check by foiling. Anyway, from here it does say that we actually want to solve, which means you just set each of these parentheses equal to 0 and solve for x. We actually have 2 solutions. Okay, so x equals 4 is 1 and x equals 2 is the second solution. 2 things I want to point out with these. If you are going to factor right now, we want this term to be 1. We can factor if it is not 1, but that would take a couple more days and a couple other lessons to teach you how to do it that way. So if it is not 1 right now, we're going to go ahead and just defer to the quadratic equation, although it could be factorable still. Okay? Another thing I want to point out is that this must be 0. Whether you are going to factor or use the quadratic, this must happen, okay? If it is not 0, you have to make it 0. So those are things to look for right now. All right, so that's how you factor. Now we are going to use the quadratic, and then we'll try some in the notes eventually. So for the quadratic, we need to know what terms are A, B, and C. So A is always the term in front of the x squared. B is always the term in front of the x. C is always the number by itself. So in this case, A is 1, B is 3, and C is -9. So I go ahead and plug this in. X equals -b plus or minus radical b squared minus 4 times A times C all over 2 times A. Now, I usually start by simplifying what is in or under the radical. So I have 9 plus 36, because I take -4 times 1 times -9, that is positive 36, and then I just bring everything else down. 2 times 1 is 2. I go ahead and finish this up. Now, there's a couple ways we can go here. If it asks you for exact solution, you want to go ahead and reduce root 45. And you can have your exact solution. If it asks you for a decimal, actually it's going to be 2 decimal solutions, you can find the square root of 45. And you can take -3 plus 6.71 divided by 2. And -3 minus 6.71 divided by 2. Notice we have to do it 2 ways. Plus and minus, because of the plus and the minus in our quadratic formula. So you finish this out, you end up getting positive 3.71 divided by 2. And -9.671 divided by 2 as your x values. Oops, that isn't part of it. There we go. Okay, so that's just a quick rundown of the quadratic and of factoring. Now we're going to move on, and we'll end up using some of those in our notes. So new vocab, we have chord segment, secant segment, external secant segment, and tangent segment. So first thing, segments intersecting inside a circle. When 2 chords intersect inside a circle, each chord is divided into 2 segments called chord segments. So these chords intersect right here at point G inside the circle. So we have chord segments. Here and here and here and here are all chord segments. Now there is a relationship that exists among these. Theorem 10.15 tells us that if 2 chords intersect in a circle, then the products of the lengths of the chord segments are equal. So you take AB times BC, that will equal DB times BE. So if we go back up here, let's try it out. We can take 4 times X, and that will equal 5 times 3. So when you solve for X, you will find the length of that segment. So x is equal to 3.75. Okay? Let's try some more. Find x. So once again, chord segments, you can multiply these and then multiply these. So we have 8x is equal to 108. Maybe I should write this out so that way you can see what's going on. We divide by 8 and x is equal to 13.5. And there's no units, so we can leave it. Okay, so that one's pretty easy. B looks a little more difficult because there's a lot of x's. This doesn't turn out to be too bad, so don't freak out. You set it up the same way. Chord segment times chord segment equals the other two chord segments multiplied. We do have to use our idea of foiling though. So we'll get more practice in for that. Okay, so the first part is actually pretty simple. You don't need to FOIL here, it's just normal distribution, so you get x squared plus 10x over on the left side. The right side we do need to FOIL. I will color code it a little bit. We take x times x, those are first, is x squared. Then we take outsides, x times 2 is 2x. Then we take insides, 4 times x is 4x. And then we take last, 4 times 2 is 8. Okay? We can combine like terms. And then we can solve. Now it happens to turn out that our x squareds cancel. That means that we don't actually have to use the quadratic or factor this time. We can just go ahead and solve like normal and get that x is equal to 2. Okay? Now, take a look here. If you were to get a negative number here, that would mean this part of the circle would have a negative distance. So make sure you're checking your answers. We'll get to some in a little bit that we definitely need to check our answers to make sure they're actually valid and make sense. All right, let's find x again. I'm going to go through these a little quicker because they're like the same problems. So we multiply our chord segments. We solve. We end up getting that x is equal to 16, I believe. Yep. For the next one, we multiply our chord segments again. And once again, we get lucky. We have some things that cancel out. We get 8x is equal to 32. So x is equal to 4. All right? Now this next problem is a story problem. The next two actually are. Kind of have to assume a few things are happening. We can either assume that this is a right angle here, or we can assume that these are congruent. You'll see what I mean in a minute. So biologists often examine organisms under microscopes. The circle represents the field of view under the microscope with a diameter of 2 millimeters. So I'll write that in. Determine the length of the organism if it is located 0.25 millimeters from the bottom of the field of view, round to the nearest hundredth. So there's two ways to solve. First of all, if we assume that these are congruent, we can state these are both x's and solve pretty easy. We need to find the length of this part by itself, which is 2 minus 0.25 or 0.75. And then we can follow through with our problem type that we've been doing, where we take chord segment times chord segment equals the two chord segments multiplied. We end up getting about 0.66 is equal to x. There's also another way we could think about this. It's similar to what we've done a couple of lessons ago, where if we know, since this is a diameter, that we put a center in, and we draw a radius in of 1, because the diameter is 2, the radius is 1. Oops. We can say, okay, if this is also 1 because it's a radius, this side of the triangle is 0.75. We have a right triangle. We are, once again, assuming this is a right angle. We are going to solve for x. So if we do the Pythagorean theorem and solve for x using this method, oops, we end up getting, let me see here, the same thing. We get the same thing, which is great. If we didn't get the same thing, something bad had happened. Anyway, they did give us a measure here, a unit, so we should write that in. So x is equal to 0.66 millimeters. The organism is pretty tiny. All right, this next one is another story problem. Phil is installing a new window in an addition for a client's home. The window is a rectangle with an arched top called an eyebrow. The diagram below shows the dimensions of the window. What is the radius of the circle containing the arc if the eyebrow portion of the window is not a semicircle? So basically they're saying this is not your radius, don't write 2 is your answer. I would suggest visualizing the whole circle. Oh man, that was bad. I know it's not the greatest, but visualize it as a whole circle and put your center in. Draw the diameter, and you know you're trying to find half of that. Now, once again, we do have to do a little bit of assuming that these lines in our chord are congruent because this is crossing at 90 degrees, okay? So that would make each of these 6 since the whole thing was 12. You can't really see it back there. Okay, and this is 2 here. So we can solve this again. We'll just give this a variable x, and we are solving for this distance. Okay, so we can set it up. Chord segment times chord segment is equal to the other 2 multiplied. So we get x is equal to 18. The thing is that is not the whole diameter. We need to add 2 to that to get the diameter of 20 feet. And the question is the radius. So the radius is just half of that, or 10 feet. All right? So hopefully that one was a little easier. Just have to visualize the rest of the circle. So now we are moving on to two segments intersecting outside a circle. A secant segment is a segment of a secant line that has exactly one endpoint on the circle. So AC has one endpoint on the circle. True B goes through the circle, but it's not an endpoint. AE, same thing, endpoint E. AB and AD. Now, AB and AD are also called external secant segments because they are completely outside of the circle. So a special relationship also exists among these secant segments and external secant segments. So if we look at Theorem 10.16, this states that if two secants intersect in the exterior of a circle, then the product of the measures of one secant segment is its external segment, and its external secant segment is equal to the product of the measures of the other secant and its external secant segment. Sometimes the words are confusing. Basically, this is saying the whole secant times the external part is equal to the whole secant times the external part. Okay? Let's come up here and try it. So we need the whole thing. That means we're going to have to do some addition. 6 plus 11 is 17. And then we will take it times the external part. Notice it's not necessarily the smallest part. Same thing over here. We need the whole thing. So this is x plus 13 times the external part. So we're going to have 17 times 11 is equal to x plus 13 times 13. So we have 187 is equal to 13x plus 169. Solve for x. So we get 1.38 for the value of x. All right, let's try some more. So this one's very similar to that last one. We take our whole thing plus the external part, equal that to our whole thing times our external part. So we get 34.5 as our solution. Okay, now the next one mixes it up a little bit. You'll notice that the x value has been inside the circle for our last two examples. Now the x is on the outside. That will change it. So once again, this side is still the same setup over here. We have 52 for the whole thing. We're going to multiply that by 25. That equals x plus 24 times the whole thing of x. So we'll distribute this x through. 52 times 25 is 1,300. You'll notice that this is not super easy to solve. It's actually one of our quadratics, so we're going to have to either factor or use the quadratic formula. But first things first, we have to make it equal 0, which is what I'm doing. So I will tell you that this is actually factorable. We're going to have to use a little bit of grit to stick with it to figure out what the correct factors are to subtract to positive 24, but they do exist. So I'm just going to pull up a calculator. I'm going to type in 1300 or 1300 and then start testing stuff. So I'm going to test 20. Now if I were to subtract these two, I would get 45. I want 24, so I think I need a bigger number. If I try 25, I get 52. We already knew those were factors because that's what we had before. That's not equal to 24. What if we try 30? Is that evenly divisible? That is not, so that's not an option. 40? Also not. 42 is also not. I'm going to go ahead and skip to 50, see what I can do there. Ooh, this is promising. So if I have 50 as one factor and 26 is the other, if I subtract these two, I do get to 24. So it looks like I need a positive 50 and a negative 26 as parts of my factors. So x plus 50, x minus 26 is equal to 0. Now, like I said, if you FOIL this back out, you will get back to this original problem. That's the point, okay? You're just making it easier for yourself to solve. So we can go ahead and solve these. We end up getting x equals negative 50 and x equals 26. Now in algebra, both of these answers would be totally correct. You would have done a great job. You are good to go. The problem in geometry is that this x is actually tied to this distance up here. We cannot have negative distance. So x equals negative 50 is actually what we would call an extraneous solution. That is not a possible solution. It shows up as it could be. But we can't have negative distance, so x equals 26 is actually our only answer. All right? So check for extraneous solutions when it comes to distance. Last theorem, we have theorem 10.17. If a tangent and a secant intersect in the exterior of a circle, then the square of the measure of the tangent is equal to the product of the measures of the secant and an external secant segment. So what it's saying is if we know this is a tangent, we're going to square it and equal that to the part times the whole secant, okay? The external part, I should say. So let's try it. We know LM is tangent to the circle. Perfect. We know that will then be the squared piece. And we equal that to the whole thing, 2x plus 2, because x plus 2 is equal to 2x plus 2, times x, the external part. So I need to distribute and simplify the left side. 144 is equal to 2x squared plus 2x. I need to solve this for 0. So I get 0 equals 2x squared plus 2x minus 144. Now, like I said earlier, if the a term is not 1, for now, just go ahead and use the quadratic formula. There are ways to solve it by factoring, but it would take a long time to explain that. So I'm going to pull up the quadratic formula. And then I'm going to plug in my numbers for my letters. So A in this case is 2. B also happens to be 2. And C is negative 144. So where I see an A, I'm going to replace a with 2, where I see a b. I'm going to replace it with 2. And where I see a c, I'm going to replace it with negative 144. And then I go ahead and solve. I'm going to get rid of these since I used them already. So I have negative 2 plus or minus 4. So I have negative 4 times 2 times 144. I know it will end up being positive, so I'm going to go ahead and just type it in as all positives. 1,152 over 2 times 2 is 4. I need to go ahead and add. And then we're going to hope that this is a perfect square. We're going to check it out. So I have the square root of 1,156. Oops, typed it in wrong. It is, it's 34, so now I have negative 2 plus or minus 34 divided by 4. So I need to split this into 2 pathways, the positive and the negative pathway. I end up getting 32 divided by 4, or 8 for x here. And I get negative 36 divided by 4, and I get negative 9 for x here. The problem is, once again, there is an x by itself, meaning we can't have a negative distance. So negative 9 is an extraneous solution, so our only answer is x equals 8. Last problem. Find x assuming that segments that appear to be tangent are tangent. So this guy, he's tangent, meaning the x squared will be the repeated piece. We need the whole thing, 45, times the external secant segment. So we need 45 times 20. 45 times 20 is 900. Take the square root. So x is equal to 30. All right. Have a great day. That is all.